So, good night. We'll continue this night with 2019 questions we have with us. So, we're able to solve or treat questions 1 and 2. We're looking at the other questions starting from 3. So, let's see what we have here. Question 3 says 170 centimeter cubes of 3.0 mole per dm cube sodium carbonate, 70 centimeter cube of 3.0 mole per dm cube sodium tricarbonate form is added to 30 centimeter cube of 1.0 mole, 30 centimeter cube of 1.0 mole per dm cube of sodium hydrogen tricarbonate. For the concentration of sodium ions in mole per dm cube in the solution is, that is the question. What is the concentration of sodium ion in mole per dm cube in the solution? So this is the question. So we have a mixture of these two, sodium tricarbonate for and sodium hydrogen triazole carbonate. So, and of course, this is the volume in centimeter cube of each. They were given the concentration as well. But the question is now asking us what is the concentration of sodium ion in mole per dm cube in the solution. So, if we have these two compounds in a solution, then we should know that for us to determine this concentration of sodium ion, then these two will have to ionize in the solution, and they do so. Sodium carbonate, if it ionizes, then it should give sodium ion plus tricarbonate 4 ions. So if we balance 2 sodium, 1 carbon, 2 oxygen balance like this. So this is to say that when sodium tricarbonate 4 ionizes, it gives us from here 2 moles of sodium ion. Then similarly, if sodium hydrogen tricarbonate 4 ionizes, it breaks up, giving us the components ion present here. Here there are 3 ions: sodium ion, hydrogen ion, and the tricarbonate 4 ion. That is sodium ion plus hydrogen ion plus tricarbonate 4 ions. So, and the equation is balanced: 1 sodium, 1 sodium, 1 hydrogen, 1 hydrogen, 3 oxygen, 3 oxygen. Then as for the charges, 2 minus 2 is 0, so charges are also balanced. Now from here we can see that this very one gives 1 mole of sodium ion. So we can say that in total 3 moles of sodium ion is given in the solution. So stoichiometrically, but the question gives us 70 centimeter cube of this with this concentration, 30 centimeter cube of this with this concentration. So what we'll be needing now to be able to determine the concentration of sodium ion in this is to find out how much moles of sodium ions are present in this is given by this 3.0 mole per dm cube of this. Also, how much of sodium ion is 1.0 mole dm cube 1.0 mole dm cube of this is also given. So that is the next thing. So take note of this equation, that from this equation 2 moles of sodium ion is given by this, and 1 mole of sodium ion is given by this. So if we do, then we can go back to say that we want to calculate the number of moles of sodium ion from each of the solutions. So we can now say that amount in moles of amount in mole of this is calculated as what? Look at it. We need to know the amount in mole of this sodium carbonate in this solution. So how do we do that? It is usually by multiplying the volume by the concentration. Now, if concentration is in dm cube, then the volume is in centimeter cube. And we must know that 1 dm cube is equals to 1000 centimeter cube. So to determine amount in mole, then we should be multiplying our concentration in mole per dm cube by the volume in centimeter cube. Understand this? So by the volume in centimeter cube, then divided by 1000 centimeter cube. What do I mean? Okay, generally, the amount in mole of any substance, of a substance in a solution, is its concentration multiplied by the given volume of the solution all over 1000. So where 1000 comes from is the fact that this dm cube has to be made consistent with this volume. So it's a conversion of this. So 1000 cube is 1 dm cube. So we just multiply the concentration by the volume. This is concentration. Anything given in mole per dm cube is concentration. We multiply by the volume, then that would have given us the amount in moles. Supposing the concentration is given in mole per liter, then this is given in liter. You could have seen that the concentration, which is mole per liter multiplied by the volume in liter, would have given us the amount in mole. But this is given in mole per dm cube, and the volume is given in centimeter cube. So people will want to convert this to liter, but there's no need of doing that. So all you do is multiply the concentration by the volume divided by 1000. So if we do so, then we should have 0.0 multiplied by 70 divided by 1000. So this will give us 0.21. This will give us 0.21 moles. 0.21 moles. So this is the amount in mole of this in this solution. Similarly, we do for for this, so that is amount in moles of this sodium bicarbonate in the given solution will be, the concentration is 1.0 multiplied by the volume is 30 and divided by 1000. So that will give um, 0.03 moles. So having done this, mind you, the question is which will determine the concentration of sodium ion. And we've seen that from this equation, the total of 3 moles of sodium ions is given. You understand? Is given. So that is from the 2 from here, 1 from here, as you have seen. So I'm going to clean this right now. So now we can now say in this that you can add the total moles of the substances in the solution. I don't know if you understand what I'm saying. If you add the total moles or total amount of the solids is what? 0.21 plus 0.03. So this gives 0.21 plus 0.03 gives 0.24 mole. So if you remember the volume of the solutions, we have this as 70, this as 30. So it means the total volume of the solution is what? 70 plus 30, which is 100 centimeter cube. So total number of moles is this, the total volume is 100 centimeter cube. Adding the two volumes together. Now we've seen that sodium carbonate gives 2 moles of sodium. This gives 1 mole of sodium, making a total of 3 moles. So we can now go ahead to say that from the stoichiometry, we have 3 moles of sodium. That's what we are saying here. So we have 3 moles of sodium being generated. So if that is the case, now we have sorry, let's see an information. So from what we have seen is that 1 mole of this gives 0.21 mole of this. Yes, 1 mole of this gives 2 moles of oxygen. Then that is to say that, I mean, they give 2 moles of sodium ion. So now from here we can now see how much, if from there, if 1 mole gives this, then how much? What I'm saying is that we saw from the equation that 1 mole of sodium carbonate gives 2 moles of sodium ion. Then how much of sodium? How many moles of sodium ion will 0.21 mole gives? That is 0.21 mole of this should give a certain mole of this, which will obtain by 2 multiplied by 0.21. Will be 0.21 times 2, 2 moles of sodium. So that will be equals to 0.21 will be 0.42. 0.42 moles of sodium ion. And similarly, we saw that from the equation that 1 mole of sodium carbonate gives 1 mole of sodium ion. So now we do the same thing. Similarly, if 1 mole of sodium bicarbonate gives, what did it give? It gives 1 mole of sodium ion. So that implies that, okay, then how much now will 0.03 moles of bicarbonate, 0.03 moles of this same bicarbonate will give 0.03. If 1 mole gives 1 mole, that it means 0.03 moles will also give 0.03 mole of sodium ion, so which is will still give us 0.03 mole. So what does this means? Now we've gotten the number of moles of sodium ion which each of the solution gives. Now the next thing is to add the total. Sorry, this there was no need for this at this point, but we know the total volume is this. So we can now set the total amount of sodium ions in the solution will now be equal to this 0.42 plus 0.03. So which should give 0.45 mole. So this is the amount of sodium ion we have in the solution. But the question says we should find the concentration in mole per dm cube. So which means we have to bring in the volume into this. So I have to bring the volume into this. So what we know is that this 0.5 mole is present in the total volume in 100 centimeter cube of the solution. You understand? But we are interested in how many moles in 1000 centimeter cube, that is in 1 dm cube, because 1 dm cube is equals to 1000 centimeter cube. So to find the concentration in mole per dm cube, we've gotten the mole, so we have to divide the mole, that is by a volume. And that means we need the dm cube, the volume, so it's supposed to be mole per dm cube. So we now say, okay, we have 0.5 mole of sodium. You understand? That's 0.5 mole of sodium in the 100 centimeter cube of the solution. Then how much of it will now be present in 1000 centimeter cube? That is a 1 dm cube. So from here you can see that if you do your cross multiplication, you're going to have 100 x equals to 0.45 times 1000. Okay, to make it clear, I'll come up here. So you're going to have 100 100x equals 0.45 multiplied by 1000. Then to get this, you have to divide all this by 100. Take 20 cancels 20 here. Then you have 0.5 times 10, which will give 4.5. 4.5. So you cannot conclude that, therefore, the concentration of sodium ion in the solution is what? 4.5 mole per dm cube. So which is the answer? So this is the answer to that question. So I hope this is understood. So all we do here is to answer this kind of question is simple. We have to determine the concentration of sodium ion for given a solution of sodium carbonate and sodium bicarbonate. That is the NaHCO3 is sodium bicarbonate. The Na2CO2 is sodium bicarbonate. So when the question is given like this, first we have to find the amount. We are given the concentration of volume of each. Multiply the concentration by the volume, divide by 1000 to get the amount in mole. That is, if you want to calculate the amount in mole of a solution given the concentration and volume, then multiply the concentration by volume, then divide by 1000. That is, if the concentration is given in mole per dm cube and the volume is centimeter cube. So this is a formula you have to know. So after knowing the amount in mole of the entire solid, then you can now from the equation you know the number of moles to give if it ionizes of the sodium ion. So it means if this amount, if 1 mole from that equation gives that amount, then what will this amount now gives? So once you know that in mole, then multiply it by the what do you call it by 1000 and divide by the given volume. Because what are we saying? From this same equation, we can see that if you're interested in the concentration will be equals to the amount in mole, multiplied by 1000 divided by the volume. So the reverse is what gives us the this very value. So to find the amount in mole, we first use this. They haven't gotten the moles of the sodium carbonate and bicarbonate. Then from the supplementary equation, we're able to know what each 1 mole of each we give of sodium ion. Then that enables us to get the moles of sodium that will be given, will obtain from that. Then now multiply that by 1000 and divide by the volume, which we did here to give us there. So I hope that is understood.